Ratios 03. Why are we looking at ratios? Well, the reason is that they serve a very important purpose. And the purpose is to give an indication of the proportion that is shared out between various groups. So, for instance, if there were two people, there's person A and person B, and I gave £100 to person A and £100 to person B, and the total amount that I gave out is £200. Well, it's given out in the ratio 100 to 100, and because we can simplify this, the highest common factor that goes into 100 and 100 is of course 100. So if I divide 100 by 100, I get 1. If I divide 100 by 100, I get 1. So the £200 in total has been shared out between two people on a 1-to-1 basis. That means that they get an equal amount. If instead I had given A £50 and I'd given B £100, and the total that I had was 150, then the highest common factor that goes into 50 and 100 is 50. So 50 goes into 50 once, 50 goes into 100 twice. So the money has been shared out on a 1-to-2 basis. And if I were to introduce a third person, C, and if A got £50, B got £100, and if I were to give C, let's say, £200, feeling very generous, then the proportions would be, first of all, I'd need to find the highest common factor, which again is £50. So 50 goes into 50 once, 50 goes into 100 twice, 50 goes into 200 4 times. So the proportions or the ratios are 1-to-2 to 4. Now this is a really good way of dealing with sharing out of anything between various groups, because it means that in total, if I were to suddenly get win the pools or something, and I give £100 now, I double everything. So I give £100 to A, I give £200 to B, and £400 to C. It will still be in this ratio because the highest common factor is 100. 100 goes into 100 once, 100 goes into 200 twice, and goes into 400 4 times. So I can then say, for instance, whatever money I have, I want to share it out between A, B, and C in these proportions or in these ratios, 1-to-2 to 4. And then whatever the money is shared out in this way. It's also used in lots of trades, and one trade is where you have a blueprint of, say, a property, and you have an outline of the property. Say you're building a house, and you want to give the builders an idea of the size of the house. So if you have something like, if this is going to be 100 meters, then I can't really draw it on that scale. I can't draw 100 meters because the map would be the size of the house. So instead, I use a scale and I say 1 to say 25. So this is the scale. And so 100 meters might be represented as, say, 1 centimeter or on the scale. So 1 centimeter would be equivalent to 100 meters. Now, because the units are very different, so centimeters and meters, you can't really put this into proportion until you converted the meters into centimeters. We know there are 100 centimeters in a meter. So 1 centimeter then would be on the scale of 10,000 centimeters, because 10,000 centimeters is the same as 100 meters. So in fact, the scale that this is drawn on is, now the units are the same. We can then cross those out and we can say that the scale is 1 to 10,000.